Alrighty, so today we are going to begin looking at angle geometry. This is going to be hopefully just a light introduction to what an angle is and some of the initial different types we will be exposed to. Now, an angle is defined as when we have two lines, so this one here and this one here, that meet at a point which we call a vertex. So where this little like laser pointed dot is showing, we have a certain we have space between these two lines. We have this thing here. We have a particular space between these two lines, which when we adjust, if my computer will stop being finicky, we can see the distance between these two lines is small here. It's very small, almost minuscule. And as I rotate this around, we can see that it gets gradually bigger. And this gap, this distance between them, is constantly increasing till these are overlapping. And then we essentially start again. Now, this distance, this distance or space between our two lines is what we call an angle. And this is measured in degrees. Now, I'm going to lay these out next to each other like this. And what we have here, hopefully it looks straight enough, but we're going to introduce one kind of primary angle and we're going to work from there. So we define this angle of a straight line as, so this little circle thing here shows us the space between these two lines. This is 180 degrees. So our degree sign is like a little sort of zero superscript above our number. So this tells us that our angle is 180 degrees. Now, if we move this in, let's say, this direction here. Sorry, my whiteboard's been really annoying today. But if we were to move this arm a certain distance, and I'm just going to temporarily rub out this 180 degrees. If we took our arm and we moved it a certain distance in the right hand direction, what do you think is happening to the size of this angle? Is the space between the lines decreasing or is it increasing? Now, to me, this looks like these are getting closer. So the angle is decreasing. And if we moved it, say, to halfway, what angle do you think we'd get here? Now, to me, this looks like 90 degrees, which is half of 180. That's what we'd expect. And the 90-degree angle is special because it is an inherent property of some of the earlier shapes we're introduced to. Now, if you look at what I've drawn here, that looks like a half-drawn rectangle, doesn't it? And that's something that I won't go into further, and because we're going to address it a bit later. But when we have 90-degree angles, we draw this little square here. This denotes that our angle is what we call perpendicular. And the definition of perpendicular is essentially just meeting one line, meeting another at 90 degrees. And this is a property in some shapes that we'll observe in the coming lessons. So what if, for example, we were to go the other way? So I'm going to take my line and if my laptop or my tablet works, Here we go. I'm going to move it this way. Now, I'm returning back to 180. If I keep going this way, our size here increases way more, doesn't it? And I can keep going. Oops, never mind. I can keep going, and this is going to increase all the way back to my starting point. So we've made an entire circle, haven't we? We've gone all the way around, and I've essentially, with this line, I've drawn out a circle in the shape with my pen, which you can't see, but as it's going around, it's essentially making a circle. So when we finally overlap these two, the angle we have, oh no, that's not what I want. The angle we have is what we call a revolution. This is 360 degrees all the way around. So it's made a complete circle from overlapping with our other line and gradually increasing along this and making its way back to the starting point. Now, that's all well and good. I've given you some of the introductory angles we'll be working with, but as humans, we like classifying certain things. We want to put, there's an entire array of different angles going from 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way to 360. That's cool, but we want a way to classify and group these different types of angles. So we're going to work with grouping these now. So going back to our original idea, from our angle of 0, which when our lines are, there's no gap between them, they're superimposed, one is on top of the other. From here to 90 degrees, so anywhere covering this space, we have what's called an acute angle. An acute angle is defined as an angle from 0 to 90 degrees. And I'm going to draw one down here for you, an example of one. And it can be anything as long as it falls between my 90 degrees and the two perpendicular lines that make this up. So I have my 90-degree angle, and we can see that our line falls between here. It could have been up here, it could have been down here, and these would have all these little angles they make. So this particular angle here, I'm going to draw in, and we draw in this little kind of arc, little line, and that shows the essentially the value of the angle. So this, we won't have to approximate it here, but essentially this angle here is acute. So that goes between, it goes from 0 degrees to 90 degrees. It can be anywhere between these values. Now, let's keep going around our original circle, around our original sort of two lines. We're at 90 here, and we are gonna go down to 180. So anywhere between our 90 and our 180, these are what we call obtuse angles. So I'm going to draw one again down the bottom here. And this one here, for example, we have there and there. So this is an example of an obtuse angle. And we'll see that this can be anywhere between 0 and 180 degrees. So an obtuse could have gone up here, could have been this angle there. It could have been an even bigger one here or somewhere here. But it could not have been here, right? Because this falls into the realm of our acute angle. So our obtuse, if we had, say, let me actually draw this in. If we had our 90-degree perpendicular line, we can see, well, this one on the left, it fell in sort of this bit here, right? This kind of quadrant, we'll call it. And that terminology will come into play a bit later in trigonometry and sort of angle relationships and things like that. But here we can see that our line falls in this space here. And that is what we'll define as an obtuse angle. If the distance in degrees is between 90 and 180. All right. So we've got one more key one that we'll talk about here. And I've kind of messed myself up with spacing here, but that's all right. If we took this, and remember when we talked about, well, when I go past 180 and sort of go here, my angle size increases all the way up to 360. And because this was the angle size we're talking about was here. So that final one, and I'm going to bring this back to where we were. This final angle, well, classification of an angle, is called, so let's go maybe from here down to here. Those are shocking straight lines. Let me have another go at that. All right. Here. Not much better, but you'll have to forgive me. So the classification for this angle, and let me draw in this here. Classification for this angle, well, we can see it goes past 180, but it doesn't quite hit the full circle where we were superimposed with the two lines as we talked about before. So this one here is called a reflex angle. And we can see that this goes past 180, and it's essentially between 180 and 360, because going from 180, if you see this line I'm drawing here, it increases, and then when it gets to 360, we essentially start the loop again. These lines are one on top of the other. So the distance between them is effectively 360. We've made an entire circle. But actually classifying these reflex angles just goes from 180 to 360. Noting that this is that big angle. You can see this thing that I've drawn is on the outside still. We're no longer looking at this little bit inside here. So once again, reflex angles we can write go from 180 to 360. Now, these are our three initial angles that we're going to talk about in our intro to angle geometry. I'll leave this here because I've already said a mouthful, but we're going to continue working with angles in the following videos. See you there.